this is King Hio 2000, here to teach you basic trig. Now, when you look at this, you can see that first of all, we're going to talk about right triangles. Trigonometry is only working with right triangles. Now, we have sin, aka sine, cos, cosine, and tan, our tangent. Another way of reminding these and knowing their formulas is by the phrase SOHCAHTOA, spelt like so. And these are the formulas. So, which is sine, opposite divided by hypotenuse. Cos, or ca, whichever you prefer, is adjacent divided by hypotenuse. Then you have tan, or toa, which is opposite divided by adjacent. Most of the time, you'll be using tan. If not tan, then sin and cos are kind of interchangeable. Next thing. Let's say that this is a 30, 60, 90 triangle. This angle where the arrow is pointing to is a 30-degree angle. Not exactly, but close enough. Now, let's say that we know that this side is 4. Now, we are going to use TOA. So, tangent, opposite divided by adjacent. Opposite is this side, or x. Adjacent, this side, or 4. So we can put in the formula x divided by 4. Now, grab your calculators. What you're going to do is based on your calculator, you are either going to type tan and then the angle, 30, or 30, then tan. It varies among calculators. After that, you're going to hit equals, and if you did it correctly, you should have 0.57735, etc. What you're going to do is, this is a fraction. This right here is a ratio. You're going to multiply it times 4, since you know that the denominator is 4 and the ratio, and you are going to get 2.309. Wait. Now that we know this, we can look at this. It says it's 2.309. Now let's plug that in and see what comes our way. We'll just abbreviate 2.309 for simplicity's sake. Now, we can then use Pythagorean to find the last one and figure out if it is a true right triangle. So 2.309 squared, 2.309 squared, that is 5.331481. Now what we can do is we can do plus 16, since 4 squared is 16, and we get 21.331481. We're going to find the square root of that, and we get 4.618. Now if you look at your theorems, you can see that triangle inequality theorem is still true. 4 plus 2 is greater, or 4 plus 2.2, blah, 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 etc., is greater than 4.618. So therefore, it is a triangle. In order to make it to a right triangle, it has to satisfy the equation, which we use the equation, so it does. Now, one last thing to check. Now, since we've got this, we can try our other formulas. Since we know, well, first of all, let's look at a different angle. Let's look at this one. That one is a 60-degree angle. Let's check cosine, which if we go back, it is, cosine is adjacent divided by hypotenuse. So we take our adjacent, and then, well, this is all after you type in cosine and then 60, since your degree angle is 60. Whenever you do sin, cos, or tan, always make sure that you type in the angle, because that's what it wants. And then you see that the cos of 60 is 0.05, or 0.5, sorry. Now, you're going to want to multiply this times what was on the bottom, aka hypotenuse. So times 4.618, and we should get 2.309, which we do. So we know that this triangle is a right triangle, or first of all, it's a triangle and it's a right triangle. Now, using this, we can find out multiple other things. Now, let's say you have a triangle, and you do not know any of the angles except what you do know is the sides. Let's say you know that this is, let's see. Let's say 75. That means that this is going to have to be greater than this side. This is also tips on building a triangle if you haven't caught on yet. Now, since this has to be less than 75, we can very easily make this 74. And for the hypotenuse, let's try a squared plus b squared equals c squared. 75 squared is 5,625. We can add that to 74 squared, and receive 11,101. So we're going to find the square root of that, which is 105.361. Okay, now first of all, we already know that this is a right angle. So we know that it's 90. So these two have to add up to 90. So we only have to find one, and then we can do simple subtraction. Okay, now we have to do the inverse of these. So what we're going to do is we're going to pick an angle. And the representation is a 0 with a line through it. I cannot type that on a keyboard because computers are stupid like that. Now, so knowing this, I'm going to delete this box real quick. I'm very sorry for the inconvenience. If my computer will load. There we go. That's better. So now, we got our triangle. We're trying to find our angles. Let's say we want to find the smaller angle. So, the best thing to do is use TOA. TOA is probably one of the best formulas. Because you almost always, emphasis on almost, have whole numbers for your legs. I can't say that for hypotenuse though. So what you're going to do is, since it's opposite divided by adjacent for TOA, you do 74 divided by 75. Now that you should get 0.986, 6666, etc. And what you're going to do is you're going to press your secondary function and then tan, and it should say tan to the power of -1. This is inverse tangent. You press enter and you get the degree of your angle, which is, in this case, 45. So we know that this angle is 45 degrees. Let's use that. So then we do 90 minus 45, and we find that this would be 45. Obviously, since it was rounded, this would be this right here would be 44, and this would be a little over 45. Just because, so it would satisfy a triangle. So this is a round. Now that you have seen how to find an angle and how to find a leg, that is all for now. Be back for 45, 45, 90 triangles.